start.
Our hack climate display allows users to explore trends in temperature from stations near them. It intends to illustrate the real effects of climate change at a scale relatable to the viewer, so that they can see the increases in temperature that have occurred over the past century in their very own home. On our interactive leaflet map, the user is able to choose their home state and scroll in towards their home. This calls a NOAA API, which then returns a list of weather stations. Upon clicking one of these stations, a different NOAA API is called, returning the data collected by that station over the past 100 years. Different stations have different levels of coverage and are recorded for differing periods. Here, we see the station at Memphis International Airport has logged 79 observations over the span of around 80 years, giving it a 97% coverage rate. From its tooltip, we can see the almost 2-degree increase in degrees Fahrenheit that has occurred over the past 80 years. We can see similar trends elsewhere. Say, for example, that I lived in Utah. At this station here, we can see a similarly high increase in temperature data, though note that the coverage is only 50% over a similar length period. Let's look out somewhere in Alaska. Perhaps there may be a greater magnitude in change due to the proximity to the poles. Here we can see one station that seems to indicate a 0-degree change. However, note its recorded period is only 6 years. Since we display a 10-year average at the start and end of the time period, any station that has less than 10 observations will indicate a 0-degree change. On the other hand, at a nearby station, Betlis Airport, we have nearly 70 observations over the course of 70 years, and can see the over 4-degree increase in temperature. Of course, these are only single data points, and thus we cannot draw a conclusion from them, but this is consistent with modern research indicating that the Earth is warming faster at its poles. Many of the difficulties we encountered during this project dealt with the relative inconsistency of the NOAA data and its APIs. Most stations do not have high coverage over a lengthy period, and sometimes calling for stations within a certain bounding box returns different sets. But once we're done with this, we can scroll down to the Global Trends section where we have prepared more visualizations.
So here we can see some global trends of natural disasters. In these graphs, you can see that on average, there's a net increase in the number of each natural disaster. Although you can also see that there are some peaks and there are some dips, but the net trend for most of them are upwards. Regarding forest fires, you can see that there's a sharp peak in the early 1990s and also in the early 2000s. But in more recent time, the magnitude seems to be lower than that of the two earlier peaks that I mentioned. However, this graph doesn't show how the forest fires have increased in intensity and have covered more area and impacted more people. So a part of the problem for the data set that we use for these graphs was that they did not include the loss of life and the area of damage for every single disaster. So we could only use a hard count. If we scroll down to floods, heat waves, and hurricanes, we also see that there's a net upward trend of natural disasters. However, the data for heat waves, you see there's more variance because some years there are no recorded heat waves. This is because the total number of heat waves in the data set are pretty low. So there's a larger variance. Well, hurricanes and floods, there are more each year. So it's easier to see a trend. So if we look here, we have two side-by-sides of what would happen if sea level rises by 30 meters, which would happen if global mean temperature rises by 2 degrees Celsius, which is the target under the Paris Agreement. So here we see that the East Coast will be mostly submerged. And in Asia, we see the plains in Eastern China will be submerged. and also almost the entire country of Bangladesh. So what's the meaning of all of this? It's hard to see just from a map. So the implications are that large population centers near the coast will be underwater. So there will be a huge cost of rebuilding infrastructure more inland. Additionally, some countries will be completely submerged, just as I said, Bangladesh. Bangladesh has almost 160 million people. So all of these people will have to be relocated somewhere else. These countries, such as Bangladesh, will be a huge source of refugees, which will cause a humanitarian crisis. Also, a lot of the areas near the coast are areas of agricultural output. So if they're flooded, then the food supply will also be affected as well. There will be a food shortage, and prices of food will also increase. For a more concrete example, we can go back to Florida. So Florida is the largest producer of oranges for the United States. If it's essentially completely flooded, we have to grow oranges elsewhere or source them elsewhere. So all orange products will cost a lot more. Okay, so if we scroll down, we see a collage of the effects that I described earlier. So we see a humanitarian crisis, floods, droughts, air pollution, forest fires, and wildlife dying out. And if we scroll down further, we have some sources. Our project can have many improvements. Scrolling back up, we can make the sea level rise into a map and allow the user to adjust the amount of sea level rise. And for further improvement, we can overlay a 3D population graph with increased density showing a larger like z-axis. And then we can also overlay areas of arable land or agricultural output and highlight freshwater sources such as streams, rivers, and lakes. You can show how many people will be affected, how much land area is affected under the sea level rise. We can also inlay the natural disaster data to our original temperature map.
And to deal with inconsistencies in NOAA data, we would like to download the datasets that the API queries and pre-process them on our end so that we leave only the stations with a high degree of coverage over a lengthy period. This would also allow us to know the temperature change represented by each beforehand, which would then allow us to color code our markers before we display them. Additionally, the NOAA data gives us access to various other metrics such as precipitation and days above 90 degrees. Global warming has been associated with an increase in these days, which are regarded as very hot, and thus this could possibly help us illustrate more of its effects.